Unit 6, we're going to be graphing these trigonometric functions. So your first lesson in this unit, you are going to be graphing just sine and cosine. And we're going to focus a lot on sine and cosine because those are the two primary ones. I mean, when you look at your unit circle, when you're finding the sine of an angle, it is that y-coordinate. Cosine of an angle is that x-coordinate. So we're going to spend, it's going to be like 3 parts of lesson 6.1. Okay, part 1, you're going to learn the graph, its special properties. And we're going to talk about transformations of these trig functions. And of course, these things will be able to be applied to the other ones as well. But these are 2 of the more important ones when it comes to graphing. So again, you're going to be learning how to graph transformations of sine and cosine today and for the rest of the week. Different things dealing with those. All right. So for your do now, you guys had to, like I said, you were finding the sine of the big 5. 0, pi over 2, pi, 3 pi over 2, and 2 pi. Those are basically, that is the original table of your sine and then also your cosine function. Okay, so when you flip over the cosine, the sine tab, because we're going to start with sine, we're going to graph it. We're going to use basically that table, that same idea, and we're going to graph it, and we're going to talk about the properties of sine. Now, the one thing I didn't like about this foldable, and I didn't feel like creating one myself, was that, as you can see, it doesn't start at 0. Okay, so you want to make sure that you add 0 in there because that is an important one. Okay, it's where the graph crosses the y-axis. So when x is 0, what's the sign of 0 again? Sine.
Oh, 0.
It's 0. Okay? Now we did the big 5, like I said for the do now. What's the sign of pi over 2? 1. What's the sign of pi? 0. What's the sign of 3 pi over 2? And what's the sign of 2 pi? 0. Now those are going to be the main ones. Like when we get to like part 3 of the first of lesson 6.1, those are going to be the only ones I use. I'm not going to use any of these other ones in between because, like I said, what's the sign of pi over 4? What's the y-coordinate of pi over 4?
2 over 2.
And because this is going to be a unit where you're not allowed to use your calculator, I'm not going to, like, I don't know where that is. I don't even know where that is. Okay, I can make an estimation. I know it's in between 0 and 1, but I'm not going to use that to do any type of transformation things with or anything like that. Okay, so it really is going to be that big 5. Okay, but also to make sure get you back in the thought process of, hey, I'm in math. My teacher needs me to know this unit circle, and hence I'm going to keep asking you these different things like, what's the sign of 3 pi over 4? It's square root of 2 over 2. What's the sign of 5 pi over 4? And 7 pi over 4. What's the sign? Okay. So again, I'm not going to apply any of these pi over 4s, but I'm definitely going to get this 0, 0. That is the x technically and the y coordinate for that graph. Pi over 2, 1. That's the next point. Pi, 0. 3 pi over 2, negative 1. Pi over 2, 0. Those points that are, again, on your unit circle create your sine graph, and it is a curve. It's not V's or straight lines. It's a curve, so when you connect them, please make sure that you're curving your line when you do it. And of course, it's just one time around the unit circle. Of course, you know we can keep on going afterwards, okay? Or I can go in the clockwise direction to get the negative values as well, which we are going to do because we need to complete out this graph, okay? If I start at 0 and I head in the clockwise direction, what value is right here at the bottom? And what is the sign at negative pi over 2? It's going to be negative 1. It is the point 0, negative 1. It corresponds to 3 pi over 2 on your unit circle. So then it's that point there. Let's keep going. What about at this point? What's this point right here? The sign is 0, yes. What's the? Negative pi. What about up here? Negative 3 pi over 2. What's the sign in negative 3 pi over 2? It's 1. And then if I go all the way around back here, I'm at negative 2 pi. And what is the sign at negative 2 pi? 0. So as you can see, I'm basically continuing this wave, this curve. These functions are called periodic functions. These curves, sine, cosine, and all the rest, they're called periodic functions because they repeat themselves after a certain period, after a certain length. And as you can see, it repeats itself. It goes up, then down, then back up, then back down. And it's going to continue that on and on and on until when? Until when? It's going to repeat that same pattern over and over and over until when?
Never.
Until never. And what's never in math? Or forever in math? So what is the domain of your sine function? Try again. Negative infinity to positive infinity or all real numbers. Because again, just because I stop at 2 pi doesn't mean that the radian values are stopping at 2 pi. No, they go further. What's the one right after 2 pi? 5 pi over 2. And what's the sign at 5 pi over 2? If I follow the same pattern, it's going to be 1. Do you see the pattern? And it's just going to continue to repeat itself. The range. Negative 1 to 1. It goes no lower than negative 1, no higher than positive 1. Are they included? So I need a, very good, unit 1 coming back. Now, amplitude. That's a new word. The amplitude is basically the height of the curve from a central line. Okay? If I wanted to draw a line that basically cut this graph smack dab in the middle, it would be the x-axis. And the amplitude is basically the height of the curve from that line to the highest point or from that line to its lowest point. How many units is that?
1.
That's the amplitude of the sine function. It will not always be 1. If that graph gets stretched or shrunk, that amplitude is going to change depending on the height from that central line. But it will always be positive. Amplitude is always positive. Amplitude is always positive. Now your period. I've mentioned this before when I said these are periodic functions. That means they start to repeat the same process after a certain length. And you guys just told me that at 5 pi over 2, I go right back up to 1 again. We started at 0. We went all the way to 2 pi, and then it's going to repeat itself after 2 pi. So the period, the length of time it takes before it starts to repeat itself, is 2 pi. I'll say that again. The period is the length of time, the length, the x value, before the graph starts to repeat itself. So from 0 to 2 pi is one complete cycle. After 2 pi, it starts to repeat the same pattern. Okay? Questions on those two vocabulary words? The period will not always be 2 pi. If it's stretched or shrunk, that is going to change as well. Zeros.
Can a period be negative?
A period can, great question. Can a period be negative? No, a period cannot be negative. It is always positive as well. Great question. Zeros. What's another word for zeros? X-intercepts. Now, unlike a polynomial function where you may have 1, 2, 3, or 4 x-intercepts, because this goes on and on and on forever in both directions, we're going to have a lot of x-intercepts. There's no way that you can physically write down every single x-intercept individually, but you can represent it generally. Where do your x-intercepts occur here on just this graph that you have right now? 0, pi, 2 pi, negative pi, and negative 2 pi. Gosh, that seems like a pattern or a way I could represent that to represent all the x-intercepts in a general sense. No, not plus or minus 2. I think you're kind of in like a good area though. How can I represent every single x-intercept if I know that it's 0, pi, 2 pi, which means the next one has to be what? No, not 5 pi over 2. That's not x-intercept. What would the next one be after 2 pi? Look at the pattern. I go 0, pi, 2 pi. So the next logical one would have to be what? Getting closer. What's the next one after 3 pi? The next one after that. I'm going to keep going until somebody gives it to me. So how can I represent that generally? I can't say I'm going to add to the general, short, condensed. Getting there. What's the next one? How can I represent all these? Because zeros are like, something, comma, 0. So how can I represent every single one of those?
Like x pi? All real pi.
Say what?
X pi?
Yes, but I wouldn't use x because that might confuse you. So let's use a different variable like n pi, pi n. Does that look familiar? Have we ever done anything generalistic like that? All your coterminal angles. Y'all remember that?
Yeah.
360k or 2 in pi or whatever it was? Yes. And n, like you said, has to be a what? It has to be an integer. So you were on it. I was like, come on. That's how we can find, every single 0 is n pi. ABS max and ABS min mean absolute max, absolute min. Which you really don't have here because there is no absolute highest point or absolute lowest points. They're really more like local. But what's the highest this graph goes? 1. And what's the lowest?
-1.
There you go. Those are your different properties of sine. Rough this time around, but I know the next time will be a lot smoother when we do this again. Okay? So these are all your properties of your sine function. This is y equals sine x. That is the graph of that function. Y equals sine x. Questions? And remember, the points for this graph come from where? And those points came from where? The unit circle. Let's look at the properties of cosine. Let's look at the properties of cosine. Let's fill in this table. Again, it's missing 0. What's the cosine of 0? Pi over 2? Pi. 3 pi over 2? 2 pi. No, I'm counting. Things like that. You shouldn't take no longer than that. All right. Again, I'm not concerned about the ones in the middle. However, what is the cosine of pi over 4? Square root 2 over 2. What is the cosine of 3 pi over 4? Careful. Because you're in the second quadrant. 5 pi over 4 is in the third quadrant. And 7 pi over 4? But again, the big 5. Those are the important ones. So 0, 1. Pi over 2, 0. Pi 1. 3 pi over 2, 0. 2 pi. And again, this is a curve. As much as you probably want to make a V, don't make a V, curve it. Cosine is also a periodic function, which means it's going to repeat its process forever, ever, and ever on a certain period. What's the cosine of 5 pi over 2? If I follow the pattern, it should be 0, because it's following that pattern. So if I follow that pattern, hopefully I won't have to write it out like I did for sine, but what is the cosine of negative pi over 2? A little louder? It's 0. What about at negative pi? Negative 1. What about negative 3 pi over 2? 0. What about a negative 2 pi?
1.
Do you see the pattern? It is a periodic function, which means it's going to repeat that same process after a certain interval, a certain period. Will it ever stop?
No.
So what's the domain?
Negative infinity to positive.
Or the set of x values such that x is an element of all real numbers. I use both because I don't want you to forget about it. Okay? The range. Negative 1 to 1 included?
Yes.
Remember, amplitude represents the height from that middle line, that midline. So it's what?
1.
1. Very good. And the period is the length of time before the graph starts to repeat itself. Look at that graph. How far has it gone from what point to what point before it starts to repeat that process all over again? 2 pi. And remember, these two, amplitude and period, they are going to change depending on if there's a stretch or shrink or anything like that. Okay. This one. I'm a little nervous. The zeros. Cosine function.
And pi over 2.
I heard three people say something at the same time.
And pi over 2.
N pi over 2. Or pi over 2 n, however you want to do it. But think about it. And n has to be a what? Integer. So let's say if n was, let's see. If n was 1, that would give us pi over 2. But if n was 2, what does that give us?
Pi?
Is there an x-intercept at pi?
No.
So it's not quite n pi over 2, but you're close. The next one is actually at the 3 pi over 2. And if I look, it's like I'm skipping that even one.
So it's always a 1 and 3.
Hmm?
Is it 2 pi over 2? Because technically you start on the 0 at negative pi over 2.
Mm-hmm. You do so if you're looking at the positive side, your first positive x-intercept is pi over 2, yes. But your next one is not until 3 pi over 2. And if I continue that pattern, the next one's not until 5 pi over 2, which means the next one won't be until. So how can I represent that space in between? Because I can't do it this way because it's going to, I can't have the one that's the even one. How can I represent that? It does involve pi over 2 though. So I'm going to put that back in there. But how can I represent the next one? How can I represent the next one? can I represent that? How can I represent that space, that gap? How can I do that? You guys are going to need to be able to see what is the pattern. What is the pattern? Absolute max and min, what are they? Max is 1, min is -1. And these are your properties for cosine. Again, amplitude, period. Definitely your x-intercepts are going to change, or your zeros are going to change depending on what happens to the graph itself. Questions? This is the graph and properties of y equals cosine of x. Both sine and cosine functions. You are taking these again down by hand. Please make sure you get the important parts. All right, both sine and cosine functions are known as sinusoidal functions. Sinusoidal functions. Reason why is because they both have the shape of a sine curve. And what you see are the two general forms of any sine or cosine function. Again, we're talking about sine and cosine first. It's actually that's the same general form for all of them. But we're talking solely on sine and cosine. A sine bx plus c plus d. Where A, B, C, and D all represent numbers. Those numbers can be pi, etc., etc. Okay? But those A, B, C, and D's are changing depending on the actual function that we're given or we're trying to graph. So, quick review. I don't expect you to write this down because you've written this down at least 2 other times at some point in time this semester. Okay? F of x represents your general function, okay? That can be anything from sine x, cosine x, x squared, whatever. But when there's a number being added on the outside, what happened to the graph? What does that mean? Which way? This one went up, okay? Y'all remember that? So if you had like x squared plus 2, that means the graph of x squared went up 2 units, okay? What about this one? When it's x plus k, but the k is on the inside. It's the left. Remember, anything on the inside was the opposite. Anything on the inside was the opposite. So when you had x plus 4 squared, that meant that the graph, that quadratic, shifted to the left 4 units. Y'all remember this? All right? This one's kind of hard to see because, of course, the font I use, but there's a negative out front. It does get flipped, but does it get flipped upside down or does it get flipped across the y-axis? Is the x-axis the y-axis reflection? Which one was it? This one was your x-axis. So it's reflected across your x-axis. This is a letter P. What was a number in front of the function? What did that do? When you saw 3x squared, what did that do? Which way? Other way.
Oh.
Vertically. These were the vertical stretch or shrinks. Okay? By that value. What about on the numbers on the inside? What does that mean? This was a horizontal. By what? Not the number. So remember, anytime it was ever on the inside, it was always like opposite. So it wasn't by Q. Not negative Q. Not X. It's the number. It's 1 over Q. Ooh, rusty. When the minus K is on the outside. When it went down. What about when the minus on the inside? And what about when the minus is on the inside with the X? That's a reflection over your y-axis. Those are your old transformations. Your old transformations. These same things happen to any function, including your sine and cosine functions. So using your transformations to apply it to your trig functions like these, okay? So that A right here is going to have what effect on sine or cosine? Which one of those transformations? It's going to be the vertical stretch part, okay? The vertical stretch part. If it happened to be a -2 or shrink, if that would be negative, then that applies some reflections and everything like that. What about D? What effect does D have on it? Up or down, depending on if it's positive or negative, okay? So this right here, this general form, is also describing the different types of transformations. On the inside, what is C going to do? That's going to be a part of the left or right. And what about the B? That's the horizontal, okay? So that's it. That's the transformations right there. That's the effect that they have, okay? So when you're looking at some different types of transformations, like what you see here, describe them. If the original function is sine x, f of x equals sine x, and g of x equals 1/4 sine x, what happened to the original f function? It was what? It's a vertical shrink by, you always say what happened and by how much, okay? So it's a vertical shrink. So Mr. Shrink. Look at B. You have f of x equals cosine x and g of x equals -3 cosine x.
Flip over the axis.
So it's gonna reflect or flip over which one?
X-axis.
Reflect over x axis. Anything else? Vertically by 3, and you can say vertically stretched. I'm not gonna penalize you if you put stretch was really a shrink. I'm gonna penalize you though if you don't put vertical or horizontal. You cannot vertically stretch something by a negative number, nor can you horizontally stretch something by a negative number. That negative is a different type of transformation. What about C? It is horizontal.
Wait, so your B is your horizontal stretch?
Or shrink. It is horizontal, but by what? Cosine of x over 3 is the same thing as saying cosine of 1/3 x. So if this is my Q, when I'm looking at those notes, is a horizontal stretch by
1/3.
Wait.
3, because it's 1 over Q.
Oh.
Gosh.
So 1 over 1/3, you keep change flip, and it's going to be just 3. What about D? So we got a reflection over the y-axis,
And then it goes up 3.
and then up 3. What about E? So using the transformations, they can be applied again to any function. Here it is applied to your sine and your cosine function. Make sure that, especially if it's a horizontal anything like C was, it's always 1 over that value. 1 over that value. And this is just part 1. Part 2, we're going to talk about more transformations, more combined. Part 3, we're going to be able to write the equations and graph them as well. Okay?